Hi, I'm Rory,
And I'm Eoin.
and this is our video for task analysis.
The first thing we're going to do today is fully define what task analysis is. Task analysis is essential as early input to design, the outcome of which is a list of all the things the users want to accomplish with the system, all the information they will need to achieve these goals, the steps that need to be performed, and the interdependencies between these steps, all the various outcomes and reports that need to be produced, the criteria used to determine the quality and acceptability of these results, and finally, the communication needs of the user as they exchange information with others while performing the task or preparing to do so. Now that we've fully defined what task analysis is, we can see that it has many advantages. But what exactly are those advantages?
There are many advantages of task analysis. They allow you to document each and every task performed within the system. This provides knowledge of all the tasks that the user would perform with the system or product. Task analysis can be described as a reference against which the value of the system functions can be tested. This provides great assistance during the design process to get better results.
Even though there are great advantages for using task analysis, there are also disadvantages. For example, task analysis can be a very time-consuming activity, depending on the level of detail. For example, if a complex problem was to rise, it is possible to get caught in what is loosely known as analysis paralysis, where more and more detail is investigated. The concept of task analysis first originated in the 1980s.
There became an emphasis on user-centered design, rather than design of system, product, or software itself. This sparked a major change in technical documentation, which only used to document the system itself. This change placed an emphasis on each and every task performed with the system, rather than the system itself. Particularly in modern times, in software documentation, long printed technical manuals that exhaustively describe every function of the software are being replaced by online help organized into tasks.
There are many situations and circumstances in which task analysis can be used. For example, task analysis is best used at the beginning of the design process. The aim of task analysis is to decompose the high-level tasks and break them down into their constituent subtasks and operations. This will show an overall structure of the main user tasks. At a lower level, it may be desirable to show the task flows, decision processes, and even screen layouts.
There are several types of task analysis and circumstances in which they may be used.
For example, critical incident technique. The main purpose of this is task data collection. It can be used at any point during the design process, but is most useful during the testing and operation phase. The critical incident technique is performed by asking experts to recall unusual or near catastrophic events occurring to them or their co-workers. The advantages of this is that the critical incident technique is broadly applicable and it allows users to divulge otherwise overlooked information. However, the main disadvantage of using this technique is that it is solely based on people's memories, and this is fallible.
Another form of task analysis is walkthroughs. This is essentially the simulation of a task. The main steps of a walkthrough are as follows. Identify a desired task that the researcher would like to perform a walkthrough on. Perform a brief walkthrough at the beginning in order to orientate the researcher to the task, especially if it's a complex one. Gather one or more respondents who have knowledge of the system that is engaged in a walkthrough. The respondent must also be notified that the walkthrough is an assessment of the system and not the respondent him or herself. Gather data as the respondent is performing the task set out. These can be data sheets, written comments, data logging, or audio or video recording. After this, debrief the respondent, clarifying any unresolved issues that may have arisen between one another. The advantages of using walkthroughs are that they yield an accurate description of a task and can be stopped for clarification, quickly set up again and executed. The disadvantages, however, are that this process is very time-consuming and requires skilled operation for validity. Also, poor preparation can jeopardize researcher-respondent relationship.
Another type of task analysis is known as ergonomics checklists. The main purpose of this is to evaluate a task's requirements. It can be used during any of the design processes. It is carried out by using the following steps. First, identify aspects of the system that need to be checked. Then, consult existing generalizable checklists for the task. These can include CRT display checklists, human engineering design checklists, and more. We can then develop our own checklists for the specific environment in which our task is being performed. We then complete these checklists selected objectively, systematically, and consistently.
Another type of task analysis is cognitive task analysis. This involves the gathering of information for a design or process through the application of cognitive theories, and in modeling the internal representation and processing that occurs for the purpose of design tasks can be undertaken more effectively by humans. Techniques that are used during cognitive task analysis are task knowledge structures, which assumes that as people learn and perform tasks, they develop knowledge structures. Knowledge analysis of tasks, which identifies the elements of knowledge represented in a task knowledge structure. Model human processor, which states that the psychological model of humans involves 3 interacting systems: perceptual, motor, cognitive. Each system has its own memory and processor. And cognitive complexity theory.
Another task analysis technique is called modeling how-to knowledge. This focuses on task-to-action mapping. The most famous approach to doing this is GOMS, Goals, Operations, Methods, and Selection Rules. The GOMS approach has 3 levels to it. The model, which is a general approach for accomplishing a set of tasks. The unit task level, which breaks users' tasks into unit tasks, then estimates the time it takes for a user to perform these. Keystroke level, which describes and predicts the time it takes to perform a task by specifying the keystrokes needed. Another task analysis technique is known as hierarchical task analysis. This involves the decomposition of a specific high-level task into its constituent subtasks, as well as any operations and plans that are related. This information is then illustrated by using graphs and diagrams, and uses structure chart notation. Structure chart notation involves ordering the activities recorded from left to right and using symbols to symbolize whether or not an action has been iterated, selected, or even if there is an absence of an action. The process of how to perform a task analysis is best represented as a structure chart. In order to break down a task, the first question that should be asked is, how is this particular task done? If a subtask is then identified at a lower level, it is possible to build up the structure by asking, why is this particular part of the task done? The task decomposition can be carried out using the following 6 steps. First, identify the actual task to be analysed. Second, break this main task down into subtasks. Third, illustrate the subtasks as a layered diagram, ensuring that it is complete. Then, we must decide the level of detail in which to decompose these tasks identified in the previous step. We then continue the decomposition process of the subtasks, ensuring that the decompositions are consistent and that they are organized and numbered properly. Once the previous steps have been followed, we then present the completed task analysis to someone else who has not been involved directly in the process of decomposing the main task, but who knows the tasks well enough to check for consistency and errors. We hope you found our video informative, and our case study will be presented separately.
Thank you for listening.